Welcome everyone to the class of marketing research and analysis. Till date we have discussed on several important factors, several important studies which are associated with the subject of marketing research. For example, we have discussed about issues like the hypothesis development, and then we started with how to test an hypothesis. Then we discussed about the test of means, which includes the t test, f test and the z test, basically t, z and f basically. So, today we will discuss on something similar, something important, which is highly relevant, right, in any study, and especially also in the marketing research study. Let us say, let us take an example. Suppose we see that there is a cold wind blowing, right. Automatically something comes to our mind. We say, we feel that maybe today it would rain, right. So, why do we say that, right? Or sometimes we feel if more people are coming to a let us say shop, there would be a higher sales, but it is not necessary. People might have come for some other reason, right. They might have visited the store to see a new product or something, but whatever, with the number of footfalls we feel that more people would buy products and more sales would happen. Suppose somebody gives a better ad, a good ad, very attractive ad, let us say, and then he feels that if people have liked the ad, then they would also buy the products, right. So, all these things that we are doing, marketers are actually using this as a very important tool to understand, and then understand the consumer's psychology, the behavior, and then try to predict, make a predictive analysis. Okay. So, this study what we are discussing today is more or less importantly called as correlation, and then we will go into regression. Okay. So, the first part being the correlation, so which we will discuss at the moment, correlation, and then we will go into regression. So, let us see what is a correlation. A correlation is basically nothing but a statistical technique that is used to measure and describe relationship between two variables. Suppose let us say there are two variables x and y, right. Generally we say y is the dependent variable or the effect, right, the effect, and x being the independent variable or the cause, right. So, whenever we are trying to establish the relationship between two variables, we are actually trying to say, is there any correlation, is there any relationship between them? Now, why do we need these relationships? These relationships, as I said, are helpful to make some predictions, right. It will help us to understand, gain insights about certain features, certain trends in the market, etc. Okay. So, let us see what is basically a correlation, but remember, many times there is also another term which is largely used when you talk about correlation. There is a word called covariance also. Students and researchers might have come through these words very often. What is this covariance? A covariance is, as if you can see the slides, a covariance is nothing but a special case, the correlation is a special case of covariance. That means what? A covariance is also a correlation, but a correlation is not necessarily covariance. That means what happens? All covariances are correlations. Basically, why? Because a covariance has its own units, but a correlation on the other hand is something that is standardized in nature, is standardized. So, it is basically a correlation is a covariance which is standardized. Okay. So, this is, if you can see this, right, covariance also measures the same, as I said. So, it is a correlation also, right, and the value between of correlation, as it is said, is basically falls between -1 to +1. Okay. Now, what if the value of two things, if the correlation value of two things is -1, what do we understand? We will just simply say, if if there is, if x and y are having a minus relationship, that means a minus 1 is the relationship, it is inversely proportional, it is inversely proportional. That means what? If x increases, y decreases, if x increases, y decreases. Suppose it is a case of plus 1, then we would say it is a highly positive relationship. It is this one was a negative relationship when you said minus 1, and this is a positive relationship where you say if there is a plus 1, right. So, the value of correlation falls in between minus 1 to plus 1. Suppose something if the relationship, the R, which is basically correlation is denoted as R, if R is equal to 0, that means you can say two variables x and y are not correlated. Okay. So, let us understand the first terms, these terms variance, covariance and etc., right. So, what does variance basically say? Now, if you remember variance was nothing but we said the square of the standard deviation the square of the standard deviation. So, what is standard deviation? Now, we said the standard deviation is something that the value of the observed item from the mean. Okay. Now, how far is the observed item from the average or the mean is termed as the standard deviation. So, standard deviation square is called as our variance. Okay. Now, if you see this, now this is, so if you look at this, S square is equal to, what it is saying is x minus x bar, x minus x square is equal to x minus x bar square, okay, divided by n minus 1. Now, this is the variance, that means the how much, when there is only one variable, how much is that variable deviating from its mean, from that we find out the variance. Okay. Then what is this covariance? Now, covariance, this is generally a doubt which students and others researchers have to a very large extent, because for example, we say the structural equation modeling is a covariance structure. Now, what does it covariance mean? To understand that, you have to understand covariance is of x and y is equal to, how it is mentioned is x minus x bar into y minus y bar, right, divided by n minus 1. So, if I say, if I understand it this way, let us go to this. Variance gives information on variability of a single variable, and covariance gives information on the degree to which two variables co-vary or vary together. That means, it is like, if you understand, just imagine like a tug of war, right, like a tug of war. If two groups are pulling each other, how, when one how would they vary, how would the how would they move. So, basically when x and y are there, with a change in x, what is the change in y. So, how would they vary together, that is what covariance structure tells us. Okay. So, let us take a simple covariance case. Now, this is a problem, if you can see the values of x are given to 0, 2, 3, 4, 6, right. The mean of the independent variable is equal to 3, right. On the other hand, the dependent variable is taken as 3, 2, 4, 0, 6, and the mean of the dependent variable is 3. Now, when I am measuring, suppose I would need to measure the, let us say individual deviation, suppose this variance, then what I would have done? I would have done the x minus x bar square or y minus y bar square. So, x minus x bar square I would have done, but in this case I am not measuring the individual variables variance, rather I am measuring the covariance. So, how do they co-vary, the x and y? To do that, what I have done is, as I explained there, x minus x bar multiplied by y minus y bar divided by n minus 1. So, how much it is coming? Now, x minus x bar is let us say the total has been done. So, x, let us say individually if you do 0 minus 3, right, plus 2 minus 3. So, you have to do it and finally it has been done here. So, minus 3 minus 1 0 1 3 x minus x bar, y minus y bar is 0 minus 1 1 minus 3 3. So, the product of the two is 1.75. So, basically you have to understand that because this is not covariance is not a standardized structure. So, it will have its own unit, okay. But when you do a correlation will come to that, a correlation is standardized, okay. As I was explaining this, you can check. So, when the data are positively correlated, now if you see the data is moving up, right, on a positive direction, that means this is to the x, the positive side of x. So, as the value of x is changing, y it is growing, right. So, we say it is a positive correlation. Now, this is a case of negative correlation, as x is improving, right, y is tending to decrease, okay. So, negative correlation. Similarly, this is something where we can't understand anything, because if you look at the scatter plot, you will see the scatter plot, you will see that the data is dispersed around, right. So, in such conditions we say that there is no relationship. How do we find a correlation between the values x and y, okay. Now, product moment correlation R, which I was just explaining, it summarizes the strength of association between two metric variables, right. So, what did I mean by that, okay. So, when I am saying, when I am doing a correlation, I am like in the last session also I think I told ki regression is basically uses two metric variables. So, y is equal to a plus b of x, where x and y are both measured in a interval or a ratio scale, that is a continuous scale basically, right. And similarly, the correlation is also takes into account that these two variables must be measured in a interval or a ratio scale, okay. It is an index used to determine whether a linear or straight line relationship exists between x and y. So, the assumption of regression is that it is a linear relationship, right. That means the relationship is the change in value is quite similar, is same, it is moving in a particular proportion, let us say, right. So, that is what it finds out. It was originally proposed, as it I have written, if you see, it is also sometimes called as a Karl Pearson's correlation coefficient, or it is also referred as the simple correlation coefficient, and or you can say the bivariate correlation also. So, do not ever get confused if you see different names, right. So, bivariate correlation, simple correlation, Pearson's correlations, right. So, all these are the same thing, it is more or less the same, it is the same thing, right. Now, how do you explain the R? Now, as I had said, R, if you see, if you remember this, so okay, R, it says, if you go to it, now what is it saying? R is equal to the covariance, right, between x y divided by what? That the degree to which x and y vary separately, right. So, that means what? X, suppose this is my standard deviation of x, this is my standard deviation of y, right. So, it says covariability of x and y together upon the standard deviation of x multiplied by the standard deviation of y will tell me the R value. Now, if you can see this, automatically you can understand that it is a unitless thing, right. There is no unit, because the units will be deducted, will be it will cut each other, right, at the numerator and the denominator, okay. So, so this is how it explains for any sample of n observations x and y, the product moment correlation is calculated as I have mentioned there, covariance of x and y divided by the sample standard deviations of x multiplied by the standard deviation of y, okay. So, if you look at this is very interesting. So, I have said this, right. From here, if you remember only this much which I just explained, you do not have to remember anything else, right. You can make your formula. Now, how is that? Let us see. Now, suppose I am saying covariance of x and y divided by Sx by Sx of y, let us say. So, how can I do it? What can I do from here? Now, covariance we knew is, what is covariance? We had written is x minus x bar, right, multiplied by y minus y bar. Okay. So, x minus x bar into y minus y bar divided by, now what is Sx and Sy? Now root over of, because why it is a root over? Now because we are talking about the variance at this, and the standard deviation is the root over of the variance, right. So it will be x minus x bar square divided by this is also this has to be divided by n minus 1 degree of freedom, n minus 1 into y minus y bar square divided by n minus 1. So you do not have to remember anything. Now you just see, if you look at the r is equal to, only thing we know is r is nothing but the ratio of the covariance. The covariance means how two variables are changing according to together, divided by the individual deviations, right. Now when I am doing this, if this is covariance is x minus x bar, right, into y minus y bar divided by n minus 1, similarly divided by whole divided by root over of x minus x bar is the individual x variance, right, variance multiplied by the y's variance, y variance and the root over. So if we do this, so we are getting the same thing again, if you and the n minus 1 will obviously get crossed. So what remains is x minus x bar, this is the formula. So x minus x bar into y minus y bar divided by root over of x minus x bar square into y minus y bar square. So this is the basic formula, right. So do not forget to write the summation, right. So summation. So this is the basic formula, right. So how do you use R? What is the use of R? Where do we use it? R has a very large use, as I said, the higher value of R, as I said, if the more the value of R, the closer the value of R is to 1, we will say that there is a very strong relationship. Let us say if a company is announcing that it is going to come with a new product in the market, right, only an announcement, it has not actually done, it has just made an announcement. Suppose it has made an announcement that it is going to come with a new product into the market. Would people buy the shares of that company, right? Is there any relationship between the announcement made by a company and the shareholders' interest in investing in the particular company's share? Now to do that, to get an idea, this is where the correlation comes into play, and thus R is useful in not only in several things, for example predicting, right. So it helps you to predict, right, it helps you to validate and also check the reliability of the relationships, right, between x and y, right. And many a times a theory is verified. Suppose you have got a theory, you have got a new theory and you say maybe there is a relationship between glaciers melting, let us say glaciers melting and let us say flying of planes over that particular area, let us say. Now I do not know. Now if suppose I am proposing a new theory or I am proposing a new kind of knowledge, now to check that the value of R or the correlation value comes into handy, it helps us, right. So as I have written, one more thing you have to understand, many a times students and researchers get confused that correlation and causation are the same thing. Now we have understood variance, covariance, correlation. Now I am coming to a fourth thing called causation. If it is written here, if you can see, correlation and causation are generally understood to be the same thing, but it is not correct, it is absolutely not correct, right. There is a line of difference between causation and correlation, right. Let us see that. I have brought two photographs, check this photograph. Now if you look at this, there is a relationship, it says ki what happens now, this is something like somebody is getting a degree, right, and his earning chances are improving, we are saying. So is it a causation or a correlation? Let us think about it, right. Similarly, second is, this is a case where we are saying ki if you go up the altitude, then the temperature will tend to go down, right, there will be less or less temperature. Okay. Now, if you look at the two cases, these two cases, what is a causation and what is a correlation, it will be very clear to you, right. So, let me show you. Now, the first example, what it is saying, that tier 1, suppose the B school college, a student gets offer, right, once the student graduates from the institute, from a good B school or anywhere, or from a good engineering college or anywhere, right, the salary after the graduation is better, right. So, the hypothesis that is coming up is students going to premium B schools get higher salaries on an average. So, are these B schools a cause for getting better jobs is the question, right. But here we cannot say, right, we cannot say. The student might have got a better job because of some other talent of that he has got, maybe it is possible, right. So, in such condition a causal relationship does not exist. We cannot say it is a cause and effect, it is the only cause, right. There could be several other causes for which the student has got a good salary, right. In the second case we said, hypothesis was, we witnessed lower temperature at high altitudes, which means the higher you go the colder it would become. So, is higher altitude a cause of lower temperature? Now, we are asking this. In this relationship, if you see, here I am saying a causal relationship exists. Now, why I am saying this? Because in the previous case we could not say that only degree was the cause, right, there could be other relationships also, right. But in this case you cannot you cannot say that it is not affecting, it is you cannot go reverse, right. So, that means what we are saying, ki there is no other explanation, there is no other explanation. So, the only explanation why the temperature is going down is because the higher altitude. So, that means what, higher altitude will lead to temperature, this is a causal relationship. So, that means what, the first was we said was a case of correlation. Yes, there is a correlation, there is no doubt about it, that students if they go to a better B school they would earn better salaries, there is a correlation, but that was not a case of causation, right. But in this case it is a case of causation, right. Now, let us take a problem, let us take a problem. So, we are this is the data, if you see the data is visible to you. Now, what we are going to do is we are going to see how it has been measured, right. Now, what it is saying, the respondents are given to you, the attitude towards the city is given. Now, attitude towards our city, towards the city is basically our y, is basically our y. So, the dependent variable, right. The independent variables are duration of residence, now how much time the person has stayed in a particular city, right, and the importance attached to the weather conditions of that city. For example, now we are saying what are the two things, now the attitude towards the city is nothing but the amount of time the person has already stayed in that city and plus the importance is citing to the weathers. Now, these are not only two variables that can be there, there can be many such variables, but in this case we have taken only two and maybe we are taking only one in this study. So, let us say what it does is basically, so let us take, so what has been done in the first case we have only taken the two, what are the two? Now, we have taken the duration of the residence, duration as the x and the opinion or the feeling about the city is the y, okay. Now, let us look at this. Now, what if you go up again, so the x, this is the x, right, this is the x and this is my attitude is my y, okay. Now, so x bar is equal to, let us see, 10 plus 12 plus 12 plus 4 plus 12 6 8 plus 2 plus 18 plus 9 17 2 divided by 12, which is equal to 9.333, okay. On the other hand, if you look at the dependent the mean of the dependent variable is 6 plus 9 plus 8 plus 3 plus 10 plus 4 goes on plus till 2, right. So, which is 6.583. Now we are interested to measure the R, okay. Now let us see. So, first we need the covariance. The covariance was, we said, x minus x bar into y minus y bar. So, if we measure the x minus x bar, which is the x bar is known to you 9.333 and the x is the individual value. So, 10 minus 9.333, 12 minus 9.333, again 12 minus 9.333, it goes on till 2 minus 9.333, okay. So, when we did this, we found this, the value is something around 170, it is not clear that the bottom. So, somewhere it is coming to 170, okay. So, 179.668. So, the covariance value, the covariance of x and y is equal to 179.668, okay. Similarly, what we need for the denominator, we need now the standard deviation of x and y, right. So, to do that, we have calculated the x minus x bar, because this is the variance we will calculate and we will take the square root of the variance, right. So, it has been calculated to 304.6668 is the x minus x bar for the x, that means the variance of x is 304.668. Similarly, the variance of y is equal to 120.9168. So, 304.66 and 120.91. So, Sx is equal to how much it is saying, 304, right. So, root over of 304.668, am I think it is clear, because the variance is the variance Sx square is equal to 304. So, when I require the Sx, I will take the root over of it, and similarly Sy, S of y is equal to the root over of 191, I hope 120.91. 120.91. So, if we calculate now, we will find the value to be how much? Now, 0.9361. So, when we divided this value, this 179.68 divided by this, right. So, we found that R is equal to 0.9361. So, now this tells us, this gives us a very clear picture that there is a strong relationship between the attitude that a person has for a particular city against the with the independent variable of how much he has stayed. So, if he has stayed long, that means if he has stayed long in the for a long time in that city, his attitude for the city is good, right. And if he has stayed for a lesser time, his attitude for the city is not so good, right, as clear as that, as simple as that. It is a positive correlation, it is a very high correlation, right. But many a times, although I am not telling you right now at this moment, there are situations where extremely high relationships in certain situations are also not desirable, but at the moment we will not talk about it. So, which that is a special case of multicollinearity, which we will go later on. So, the total variation, so yes. So, once you have calculated the R, now this R that we have calculated, this R is not, if we take the square of this R, now R square is something, a term called as coefficient of determination, coefficient of determination, okay. So, what is basically this? Now, it is saying, now in terms of regression, although I have not come to regression, so just imagine for the moment, I will explain once I come to regression. So, imagine that the higher the value of R is, the higher is the explanation power of the independent variable for the dependent variable. That means, this if the R square is nothing but it is the ratio of explained variance divided by the total variance. Now, let me show you otherwise how it would look like in a graphical way, if you want to see that. Suppose let us say this is something like the value, the y bar, right, and this is something like the y predicted, right, the y predicted. Now, and let us say this is my observed value of y, right. So, my total variance or total variance is explained as, in this case my total variance would be how much of variation is happening. Now, this y I minus y bar, so this entire is my total variation, right. What is my explained? Now, this is my y hat is the this one, y is equal to a plus b of x, right. So, y hat, the predicted value is what we are talking about, that y hat is y hat, let us say SSY or sum of square total y is equal to, is the total, right, which is y y minus y bar square. Okay. On the other hand, if we talk about, there are two other variations variance that is coming up in this case. One is called the explained variance and the unexplained variance. Now, this part y hat minus y bar square, this one, right, y hat predictable predicted and the mean. Now, if you take this is called the explained, this is called the explained variance, right. This is called the unexplained variance, unexplained variance, or it is also called as residual or error, right, however you may understand, right. And this is the regression, basically we talk about the SS regression, we say is the explained variance. So, for any researcher, the entire research, the total variance is this total, this is y the observed value minus the y bar square, but this so if I write this, it will look like y minus y bar square is equal to nothing but y minus y hat square plus y hat minus y bar square. This is how it will look like. Okay. Let me wind up at the moment. We will continue in the next session. We will come with little more of correlation, and then we will get into regression, right. This is a very important, very important and very interesting and very useful subject, because it is highly utilized in any kind of studies where you find a cause and effect or you find correlation, right. So, you need to study understand whether there are significant relationship between variables or not. To do that, this correlation and regression are very important, right. So, we will continue in the next session with the same, right. Thank you for this session.